Hey guys, welcome to another video from Mastering React Native TurboModules series. In this episode, we will talk about executing code on different threads. And in previous episode, we discussed basics of creating and using different features of TurboModules. So if you didn't watch the previous ones, I highly encourage you to do so. All of the code we'll use in this video and from actually all of the videos is available in here on my GitHub / Swift TurboModules, and you can find all of the code on branches corresponding to each video. So yeah, let's jump in. So as I mentioned, we will talk about threads, and in React Native, we've got 3 main threads, and I'm discussing the iOS side of things, but it's pretty similar on the Android side of things. So yeah, first of all, we've got the main thread, which is also referred to as the UI thread, and it handles all of the UI operations and maintains a responsive user experience. So for example, if you'd update like a UI view, you would need to do it on the UI thread. So we would need to explicitly jump onto the UI thread, and then we can actually reference any of the UI kit elements on screen. Next thing is the JavaScript thread, which executes JavaScript code, but not exclusively. And this is created by React Native, and it's like for executing React Native JavaScript code. And then we've got the native modules thread, which is also a shared pool allocated by React Native for us to execute code of our native modules. So a React Native app can also have additional threads, for example, from a library that you are using, or you can also create your own, and we will discuss this in this video. So yeah, let's jump in, and let's first of all discuss how you can actually see and check which thread our method is running on. So probably the simplest way is that we can just print which thread we are on. So let's add some print statements in here. And also let's remove those breakpoints. Let's redo it and see. All right, so it's now built, and we can do press to start reading. And for example, in here, as you can see, we've got a current thread printed, and this is an NS thread. This is the address of the thread. We've got the thread number, which is 3. Unfortunately, there is no name, but let's just press to retrieve, which calls this method. And in here, as you can see, we've got actually a JavaScript thread printed. So this is because if we go to native local storage.ts, as you can see here, the get item, it's a sync method. So we've got no like promise or anything. It's just a sync method. It's called synchronously. And so React Native actually calls this synchronous native methods on the JavaScript thread. So if I do it else again, you can see the runtime that JavaScript is the current thread. So this is a plus, and this is also something we need to keep in mind, because for example, if we would do let's say here thread.sleep so if we would do thread.sleep for like 2 seconds in here, rebuild, then once it builds, the whole JavaScript thread will be blocked for 2 seconds, which is actually a dangerous thing, because if the JavaScript thread is fully blocked, it's currently, like in this case, it's sleeping, but you could be doing some advanced calculations or whatever. This means that our app will be unresponsive. As you can see, I'm pressing, and only after those 2 seconds, our JavaScript thread was free, and then we could execute more stuff. So yeah, as you can see, current thread, JavaScript, and then I was pressing on the press to store greeting, and only after 2 seconds it unblocked and was able to process my clicks once again. So this is something, probably most important thing. If you would have to take away one thing from this video, I think not blocking JavaScript thread would be the most important one. So yeah, let's remove it and don't do this. So yeah, we can just print the current thread, but there's also a nicer way. We can place some breakpoints. So for example, press to store, we've got a breakpoint here. And if we expand this left section, you can see thread 19 queue, com.meta.react.turbomodule manager queue. And this means that this is code on the native modules thread. So yeah, set item, this comes from the Objective-C side, and then we are on the Swift side. So yeah, here you can check actually the thread, and if you check around here, we've got many threads running. The first one, thread 1, is the Apple.com main thread. So this is the thread that actually we need to use when we interact with UIKit elements. So yeah, we can also check the, let's go back. Yeah, we can also check the get item. So press to retrieve. And as you can see, com.facebook.react runtime.javascript. So this is actually being invoked on the same JavaScript thread that you run, for example, your console log on. This is the same thread right now. So this is why it's dangerous. Okay, so now that we've got this out of the way, how to actually check which thread we are running on, and this will be useful as we progress through the video. Let's discuss something and this will give you a deeper understanding on how queues and dispatch queues and how you can create your own queues in Swift and how it works. So there is this topic of Grand Central Dispatch, which in short is GCD, and it's basically the foundation of, and it's an Apple level API for managing concurrent operations. And this abstracts away threads from us, so we don't need to worry about like creating, destroying, and managing the thread itself. We can just work with queues. And queues also are like system optimized. So for example, there is a thread pool and the system reuses threads intelligently. So we don't need to actually think about all of this. How we operate with queues is that we submit closures to a queue. GCD, the Grand Central Dispatch queue, picks an available thread from its pool, gives it this work to this thread, and then returns the thread for reuse. So it's actually way simpler to work with threads because of those queues. And you can think of queues like to-do list. For example, you add a task, the system figures out the best way to execute the task, and you don't need to think about anything else. So an example of a queue like this is dispatch queue.global. So if we see, yeah, we can actually do dispatch queue.global and specify the quality of service. And this is kind of like beyond the scope of this video, but there are multiple quality of service that you can specify, and they basically define how important for the system should this task be. You can do like, I don't know, user initiated. And this would mean that, you know, it's pretty important. There's also like background, which is the lowest priority. So yeah, we can just omit this for now and do that async. And for the sake of an easy example, let's print the current thread once we are on the global background thread. So dispatch queue.global in short, puts us on the global background thread we can use for calculations. So if we would block and like a thread that sleep on this thread, the JavaScript threads would still be safe. So let's do press to retrieve. And as you can see here, we've printed current thread, number 13, name equals null, and then once again the JavaScript thread. So this is working. This is working fine. So in this closure, we are on the background thread. But what if we want to do some background work and then from the result of this background work, jump back to the UI thread and actually execute some work on there? We could actually simply do dispatch queue.main. Well, what is going on with this formatting? Okay. So dispatch queue.main.async, this would put us back on the main thread. Let's, inside of this closure, print it. So actually, when we go in, we are on the JavaScript thread, then we jump onto the background thread, and then we jump onto the main thread. And we should see all of this in the print statements. So press to retrieve. As you can see, now that the current thread was printed from the JavaScript thread, then we were on the background thread, and then we are back again on the NS main thread with the name main, which is like the main thread we discussed. Cool. So you may have seen that there is also that async, but there is also that sync. And the main difference is that sync blocks the current thread. So we would go back to kind of the previous scenario where we blocked the thread until the work inside of this closure completes. So yeah, you rarely have to use that sync, but yeah, you mostly use async. You should mostly use it, and only if you know what you are doing, you should use sync. All right, so the next topic is, because for now we've been kind of like reusing the available system queues, but what if we want to create our own? We can also easily do that. Let's create new private-led custom queue, dispatch queue, and give it a label. And let's modify this example a bit. And let's go through what's happening here. All right, so by default, dispatch queue with no additional options other than the label gives us a serial queue, which means the task executes one at a time in order. So we've called this dispatch queue a custom queue, and we put some async work on it. And in this case, we just print call1, current thread, then sleep for 2 seconds, and print call1 after sleep. And then we put another thing on the queue and just call to current thread. So let's rebuild. Let's see what's the result now. So since this is the serial queue, it should actually like first execute all of this and then execute all of this afterwards, one after another. So press to retrieve, and you can see current thread. So current thread, because this is async, we didn't have to wait for this at all. We immediately jumped to current thread. As you can see here, we printed JavaScript. And then after, we went to call1 current thread, which is our own custom thread. Then we did call1 after sleep, and then call2. But this is useful, for example, if you want to protect some shared mutable state like database or file access or whatever. But in most cases, you would probably want to use an attribute here. Attributes dot concurrent. And so what this is doing, this allows us to run tasks in parallel, which is something that we not always, but in most cases want. So you will see how this attribute changes how this code behaves once this builds. All right, so yeah, let's see, press to retrieve. All right, so first we've got call1 current thread. So this is actually first thing that got executed. Then we've got current thread, the JavaScript thread. Then we've got call2, and then we've got call1 after sleep. So this is because this is a concurrent queue. So we didn't have to wait for this whole block to be executed only to execute this one. We first executed this, then actually this, and then this, then after sleep we executed this. So yeah, this is how the concurrent queue works. And you can do, I don't know, like some batch processing, you can do multiple network requests at a time, etc. All of this stuff is possible thanks to this nice and easy abstraction of a dispatch queue. And in some more modern way, you could also use Swift actors, but this is totally outside of the scope of this video. And if you are interested, you can also check out different YouTube video about Swift actors. All right, so now that we've got all of this out of the way, let's actually do some async methods in TurboModules. So we can implement a new version, getItemSync at setItemSync inside of here. And yeah, you should do pod install. All right, so the project now reboot after a pod install. And in the background, in the meantime, while it was building, I've added a new button to actually call getItemSync in here. So you've got the press to retrieve sync method. Cool. So now once we go to localstorage.h, we can command click on this native local storage spec. And as you can see, we've got some new methods because CodeGen generated them for us. So there is getItemSync, which accepts the key. And then two methods, resolve and reject, which is rct promise resolve and block, and rct promise reject block. And the same thing goes from setItem. So now on the Objective-C side, we will have to implement those two methods and bridge them to Swift. GetItem async and setItem async. Right. So now we need to, as you can see, both of them return void. And in the sync variant of those methods, we had to return the actual value. And this is because this will be a promise. So you have to resolve the promise with the value instead of actually like returning the value. I just pasted in this getItem async at setItem async, and I had to import React for Swift to see this rct promise resolve block. And in this example, this has to be escaping because this will outlive the closure that we are passing this into, because this will be moved into the dispatch queue.global and resolved there. So all of this is doing, it's actually like just, we are calling this method, we are jumping on the background global queue and retrieving the value and resolving the promise. And same thing goes from setItem async. If we really wanted to, we could actually also use our custom queue as before. And then in the Objective-C side, we have to bridge this local storage, setItem async, key, value, and resolve. We could actually also pass reject, but in this case, there is like this operation shouldn't fail. But in like production ready code, you should actually also handle the error for key and resolve. And let's rebuild. Let's see. All right, so now this is built and we can do press to retrieve. And this will be called, this is calling this get item async. And as you can see, the default queue that this is called is the TurboModule manager queue, which is the native modules queue. But then we go into the Swift side and we jump in onto our custom queue, which is concurrent, and execute the work there and resolve the promise on our queue. And this works. We got hello expo. And if we go in here, you can actually see get item async. We just await it. So the main difference is in here, we don't have to await. In here, we await. And then we alert this. And this is really useful. For example, if this operation would take a really long time to calculate, we don't want to block the queue. And we also, in this case, jump onto our custom queue, so we don't also block the shared pool for all TurboModules. So yeah, I think this is really nice way of like executing a long running functions on our custom queues. So yeah, summing up, by default, native modules run like the async methods run on the TurboModule queue. You can use dispatch queue.global for some quick jump onto the background thread without creating your own queue. And basically the main top one takeaway is that you should never block either main thread, which is from like the UI thread from the system, and the JavaScript thread. You should always avoid doing heavy operations on their calculate on some background thread or your custom queue, and then only send the result back to those two queues. Thank you for watching this video. You should consider leaving a like, commenting out below the video, and giving a subscription to the Close Stack YouTube channel. And I will see you in the next one. Thank you.